Hello children, welcome to Math Park. Our today's topic is logarithms. It is chapter 8 from the book Concise Selina, class 9 ICSE. We are going to solve exercise 8A over here. So children, after going through the video, if you like it, please share with your friends. And if you are new to the channel, please subscribe. So in this chapter, we are going to learn how to express the given expression in the logarithmic form. And if it is given in the logarithmic form, we will be writing in the exponential form. The logarithm is basically required to solve the lengthy calculations in the easy way. Children, you will be getting the log tables as you go to the higher classes. For now, you are going to learn only the basics and the chapter is very, very easy. So you have to remember, this is the exponential form. A to the power b equals c. So log of this can be written in the log form as log of c to base a equals b. So 5 cube is equal to 125. So writing this in the logarithmic form, we get this as log of 125 to base 5 is equal to 3. So again, understand the relation here. 5 to the power what will give 125? So 5 cube. So this is how the answer here. So log of 125 to base 5 is equal to 3. Writing 3 raised to minus 2 equals 1 by 9 in the log form. Remember, the base remains as the base always. So comparing with this, you get log of 1 by 9 to base 3 is equal to minus 2. Come on, solve along with me. So you get 10 to the power minus 3 is 0.001. So log of 0.001 to base 10 is equal to minus 3. Come on. Before me, I want you to do this. Check your answer. So you have log of 27 to base 81 gives 3 by 4. Moving to the next question. Express each of the following in the exponential form. Now we express in the logarithmic form. Given log form, we will be writing in exponential form. So we have a raised to b equals c. The log of c to base c is equal to b. Then a raised to b equals c. This is what we are going to do here. So log of 0.125 to base 8 is equal to minus 1. So you get 8 to the power minus 1 is equal to 0.125. So you get 8 to the power minus 1 is equal to 0.125. Log of 0.01 to base 10 is equal to minus 2. So we have 10 to the power minus 2 equals 0.01. Next, log of a to the base a is equal to x. So we get log of a to the base a is equal to x. So we have a to the power x is equal to a, capital A. Next, log of 1 to the base 10 is equal to 0. So we have 10 to the power 0 equals 1. Solve for x. You have log of x to base 10 is equal to minus 2. First, we write this in the exponential form. So we get 10 to the power minus 2 equals x. Now 10 to the power minus 2 equals x. So which is the a raised to minus m. We have learned the exponents. We have a raised to minus m is equal to 1 upon a raised to m. So this is how you get x is equal to 10 to the power minus 2 becomes 1 upon 10 to the power 2, or which is 1 by 100, and 1 by 100 is 0.01. So this is how we got the value of x as 0.01. In question number 5, there are many questions. I'll be taking just a few. Same like question number 4 we are going to do here. So log of 100 to base 10. So let us write in the form of log. So we have log of 100 to base 10 is equal to x. Then we write the exponential form of that. 10 to the power x is equal to 100. Now 100 is 10 square. So we get 10 to the power x is equal to 10 square. And comparing when the bases are equal, we have the powers equal. So this is how you get x is equal to 2. So thus, log of 100 to the base 10 is equal to 2. Let us take 1 with the decimal. So we have log of 0.1 to base 10 equals x. Writing in the exponential form, you get 10 raised to x is equal to 0.1. And 0.1 is 1 by 10. And again, so 1 by 10 means it is 1 upon 10 to the power 1. So 1 upon 10 is 1 upon 10 to the power 1, which becomes 10 to the power minus 1 as 1 upon a raised to m is equal to a raised to minus m. And comparing, if the bases are equal, we get the powers are equal. So you get x is equal to minus 1. Let us take 1 with the fraction now. So we'll solve the sixth one. We have log of 1 by 16 to the base 4. Let us take it as x. So you writing in the exponential form, 4 to the power x is 1 by 16. Now 4 square is equal to 16. So it is 1 upon 4 square becomes 4 to the power minus 2. Comparing, if the bases are equal, we have the powers equal. So we get x is equal to minus 2, or log of 1 by 16 to the base 4 equals minus 2. Let us solve one more. So we do the seventh one. So we have a log of 27 to the base 9 is equal to x. So writing in the exponential form, you get 9 to the power x is equal to 27. Now 9 and 27 are related with 3. So we make both the places base 3. So 9 is 3 square. So 3 square to the power x becomes 3 raised to 2x. 27 is 3 cube. So this is how you get 2x is equal to 3. Comparing the, if the bases are equal, the powers are equal. So you get x is equal to 3 by 2. So solve the similar question. State true or false. So if you are asked state true or false and justify, you will have to show steps here. So log of x to base 10 is equal to a, and 10 to the power x is equal to a. Let us write in the exponential form. You get this as 10 to the power a is equal to x. So we don't have this as same. So here you got 10 to the power a is equal to x, whereas it is given as 10 to the power x is equal to a. This is how the given statement is false. Next, we have if x raised to y is equal to z, then y is equal to log of x to the base z. So if you have to write this in the logarithmic form, this is going to be log of z to base x is equal to y, whereas here it is given as log of x to base z is equal to y. So this is how the given statement is false. Moving to the third one, you are given log of 8 to base log of 8 to base 2 is equal to 3. Writing in the exponential form, you get 2 cube is equal to 8, and this statement is true. Let us take another one. So we have log of 2 to base 8 is equal to 1 by 3. Now writing this in the exponential form, we get 8 to the power 1 by 3 is equal to 2. Now 8 is 2 cube to the power 1 by 3. So which we again get it as 2. So this is how both the statements are true, because on solving, we get the both the value, like 2 cube is equal to 8, and we got here 2 is equal to 2. Moving to question number 7, find x if log of x to base 3 equals 0. We are going to solve a few out of these. So remembering how to write the logarithmic form into the exponential form. So log of x to base 3 is equal to 0. So we get 3 raised to 0 is equal to x. We have a law a raised to 0 is equal to 1. So this is how you get x is equal to 1. Or log of 2 base 5 equals 1. Writing in the exponential form, we get 5 to the power 1 is equal to x minus 7, and 5 to the power 1 is 5. Shifting this minus 7 over here, so you get x is equal to 5 plus 7, and which is 12. So this is how you got x is equal to 12. One more let us solve, and then the questions are similar. They are easy, children. You need to solve yourself. So solving the last one of this, log of 2x square minus 1 to the base 7 equals 2. Writing in the exponential form, you get 7 to the power 2 is equal to 2x square minus 1. So 7 square is 49. Shifting this minus 1 over this side, it becomes plus 1. So this is how you get 2x square is equal to 49 plus 1, which is 50. And then x square is equal to 50 divided by 2, which is equal to 25. Taking the square root on, we get x is equal to plus or minus 5. Now we move on to question number 8. Evaluate log of 0.01 to base 10. Let us solve few questions out of this. Writing log of 0.01 to base 10 is equal to x. In the exponential form, we get 10 to the power x is equal to 0.01. and 0.01 is 1 by 100, which is 1 upon 10 square, and 1 upon a raised to m is equal to a raised to minus m. So 10 raised to x is equal to 10 raised to minus 2. When the bases are same, we equate the powers. This is how you get x is equal to minus 2, or log of 0.01 to base 10 is equal to minus 2. Let us take another one. So we have log of 1 by 8 to base 2 equals x. Let us write in the exponential form. You get 2 to the power x is equal to 1 by 8. Now 8 is third power of 2. So we get 1 by 8 as 1 upon 2 cube. 1 upon a raised to m is a raised to minus m. So we get 2 raised to x is equal to 2 raised to minus 3. If the bases are equal, we equate the powers. So you get x is equal to minus 3, or log of 1 by 8 to base 2 is equal to minus 3. Let us take one with the decimal. So we have, let us take log of 16 to base 0.5 is equal to x. So we get 0.5 to the power x is 16. 0.5 we can write as a fraction, which is 5 by 10. 5 by 10 is 1 by 2, and 16 is the fourth power of 2. So 1 upon 2 to the power x is 2 to the power 4. 1 upon 2 to the power x is 2 to the power minus x. So 2 to the power x is minus x is 2 to the power 4. Comparing the equations, when the bases are equal, the powers are equal. So you get minus x is equal to 4, or x is equal to minus 4. Got it? So similar way you need to solve the other question, children. Question number 9. Given log of x to base 2 equals m and log of y to base 5 equals n, express 2 to the power m minus 3 in terms of x. So you are given log of x to base 2 is m and log of y to base 5 is equal to n. Let us write this in the exponential form. 2 to the power m is equal to x and 5 to the power n is equal to y. Now let us solve the first one here. So we have 2 to the power m minus 3 is going to be 2 to the power m divided by 2 to the power 3. We have a raised to m divided by a raised to n is equal to a raised to m minus n. So using this law, now 2 to the power m is already given to you as x. According to this, we have written the exponential form, which is x. So we get this as x upon 8. So this is how we have expressed 2 to the power m minus 3 in terms of x as x by 8. Let us do the second one, which is 5 to the power 3n plus 2. Now remember, we have 5 to the power n equals y, using this log of y to the base 5 is equal to n. So a raised to m into a raised to n is equal to a raised to m plus n. So vice versa, a raised to m plus n can be written as a raised to m into a raised to n. So we write this as 5 raised to 3n into 5 raised to 2. Now you have 5 raised to n is given. So this can be written as 5 raised to n and then the cube of this. So because a raised to m raised to n is equal to a raised to mn. So multiplied by 5 square, which is 25. Now 5 raised to n is equal to y. So we get this as 25y cube. Got that? Instead of 5 raised to n, we are writing y. So this is how we have expressed 5 to the power 3n plus 2 in terms of y. Got it? Next question, we have 10th one. If log of x to base 2 equals a and log of y to base 3 equals a, write 72 to the power a in terms of x and y. Okay, so what is given to you? Log of x to base 2 equals a and log of y to base 3. So writing this in the exponential form, we get 2 to the power a equals x and 3 to the power a equals y. Now you have to write 72 to the power a in terms of x and y. Let us do the prime factorization for 72. Dividing by 2, you get 36. 36 divided by 2, you get 18. 18 divided by 2, you get 9. 9 can be divided by 3. So 3 3s are 9 and 3 1s are 3. So 72 is 2 cube. So it is 2 cube times 3 square. Now you have to find 72 to the power a. So 72 to the power a is equal to 2 cube into 3 square to the power a. Now we have a raised to m raised to n is equal to a raised to mn. So therefore you get 72 to the power a equals 2 to the power 3a into 3 to the power 2a. Thus we have 2 to the power a equals x. So we write this as 2 to the power a cubed using the same law into here again we have 3 to the power a equals y. So this we can write as 3 to the power a and the square of this, and 2 to the power a is nothing but x. So we get this as x cube times 3 to the power a is y square. So this is how we have written 72 to the power a in terms of x and y. Children, if you like the video, please share with your friends. And if you are new to this channel, please subscribe. Thank you for watching. Have a good day.